Okay, for the second day of 5.3 with your homework, I'm going to take a look at 5 problems actually today. I'm going to take a look at one problem that's similar to like one we did in the homework for day 1. The next 2 are going to deal with multiple angles where you don't have just an x here, you have something else, and how I solve that. And you're going to notice there's a difference here. This one doesn't have over the interval from 0 to 2 pi, so this is one where I have to write an equation to solve the answer. This one wants specific answers. And then the ones on back look similar to ones that we've done in section 1, and they're very similar in terms of what we're about to do. It's just going to require us to use our calculator a little bit more. Alright, so starting with the first one, I've got that I want to solve 2 secant squared plus tangent squared minus 3 equals 0 for all x in the interval from 0 to 2 pi. The good news is I have squared terms, and I know, because I remember my identities, that secant squared and tangent squared are in the same identity. So I can easily change one into the other. Since I don't have a regular secant x or tangent x, it doesn't matter which one I switch it into. If I had, say, minus 3 tangent x, then I would need to change this into tangent squared. But for this one, can change it to whatever I want. So I'm going to change, I'm going to change tangent squared into secant squared minus 1. So I'm going to have 2 secant squared x plus, and then, like I said, all you got to do is make sure that you look at your identity correctly. I know that tangent squared, if you manipulate that identity, is really equal to secant squared minus 1. So I can change this into secant squared x minus 1, still have the minus 3 there. So if you decide to change it into this one into tangent squared x plus 1, same thing's going to eventually happen. It'll look a little different, but you'll get the same answers in the long run. Alright, combine like terms, that means I have 3 secant squareds of x. Combining those, I have a minus 4 equals 0. Solve for the secant squared. So I would have to add 4 and divide by 3. Take the square root of both sides. So don't forget your plus or minus. And then, like I usually do, if it's a secant, cosecant, or cotangent, I switch it into one of the 3 original trig functions I'm used to. So I'm going to change this into, I can get rid of the square because I'm actually taking the square root. I can get rid of, or I can change this into cosine of x is equal to plus or minus, and then take the reciprocal of this. So if I take the square root of them each separately, it's going to give me the square root of 3 in the numerator. Square root of 4, of course, is 2. And now I get something right off the unit circle that I'm used to, which is good. Means I don't need a calculator to help me solve this one. Plus or minus, so I'm going to be in all 4 quadrants now, so just go ahead and draw a ray. And like I've always told you, I don't draw the ray to be accurate. It looks like it's a 45. I know it's not 45 because it's an x value of square root of 3 over 2. I know it's a 30-degree reference angle, or pi over 6. I just draw the ray so that I can see which quadrant. So that means this is pi over 6. This one would be 5 pi over 6, 7 pi over 6, and 11 pi over 6. And those are my 4 answers for this particular problem. Alright, on to the next 2. The ones that have multiple angles. When I see a 3x or a 4x or something that's not just x there. Well, when that happens, that means I'm going to have more answers than I think I'm going to have. For this first one, because I have to write an equation, actually not going to be that bad. What you want to do, like any problem, is get the tangent of whatever this angle is by itself. This one, it already is. But for example, if there was a 4 in front, I would want to divide both sides by 4, or if there was a 3 plus this, I'd want to subtract the 3, whatever the case may be. So I'm going to say it's the tangent of 3x. In your mind, try to think of that as x for right now, is equal to 1. Well, where is tangent equal to positive 1? Well, I know in my unit circle that's going to happen in the first and the third quadrant. Either they're both positive or both negative. And I know that the x and y values have to be exactly the same to get 1, so I know that this is a 45-degree reference angle. And so I am looking at pi over 4 and 5 pi over 4. Now those are evenly spaced, so I can write one equation. I would normally say x is equal to, but this isn't x, it's actually 3x is equal to. And then write my equation. It's pi over 4 plus, I need to go pi unit around before I hit the next ray, so it'd be pi n. And then normally we'd be done, but because this is a 3 and I don't want that to be 3x, I want it to be x, I just divide everything by 3. And that's going to give me x is equal to, this would become pi over 12 plus pi over 3n. and that would be my answer. Pick any integer you want for n and plug it in here. You will get a number that when plugged in for x will actually give you the tangent of that angle equals 1. Alright, so basically just don't be thrown off by the 3x. All it does is it adds this one step of dividing by 3 at the end. Alright, now this one a little bit different because it's not asking for an equation, it wants specific answers instead. So I am going to do the same thing. I can see it's not x, it's something else. Same idea, try to get the secant of that angle by itself, so I want to get rid of the 8. So I'm going to divide both sides by 8 and just try to get your mind to think of that as being an x for right now. Obviously it's not. And because it's secant, I want to change it to one of the 3 trig functions I'm used to working with, so I'm going to go with the cosine. Its reciprocal is equal to 1/2. And then I'm going to draw myself that little unit circle again and say, well, it's cosine, it's a positive 1/2, so I know it's going to the right. And I know if the cosine is positive 1/2, it's a reference angle of 60 degrees, or this would be pi over 3 and 5 pi over 3. And if I was going to say that this was actually x and I was going to list my answers, I would say x is equal to these two. Well, realistically now it's 4x is equal to pi over 3 and 5 pi over 3. And of course I'm going to have to divide both of them by 4. And you end up with pi over 12 and 5 pi over 12. And the trick here is these aren't the only answers. If you think about when we did the graphing, anytime you have a number bigger than 1, a graph that looked like this normally, the bigger that number got, the smaller this became, or that we squeezed it, we said horizontally. So our graph would actually look more like this. And you can look, you can see it crosses the x-axis more times. Basically, kind of a rule of thumb, whatever is being done to x here, it's going to do that to the number of answers you have. So typically on the unit circle, you have 2 answers. I'm actually going to multiply by 4. I'm actually going to have 8 answers. And so you ask, well, how do I get the other ones? You can do it one of 2 ways. The easiest thing to do is, you remember how you found the period when we were graphing? The period was always 2 pi divided by b. Well, for this particular problem, our b value is 4, so it's pi over 2. Well, all you need to do is add pi over 2 to this over and over and over again until you reach 2 pi. So as soon as you write down the first number that's bigger than 2 pi, you know you've gone too far. So for example, I'm going to say x is equal to pi over 12. I'm going to ignore the 5 pi over 12 for now, and I'm just going to add pi over 2. Now you're going to want a common denominator, so I'm going to say that that's actually 6 pi over 12. So the next one would be 7 pi over 12. Add another 6 pi over 12 will give me 13 pi over 12. Notice that this is still less than 2 pi. Add another 6, it would give me 19 pi over 12. That's still less than 2 pi because it's less than 24. If I added another 6, that would give me 25 pi over 12. That's too big. That's over 2. And notice I went from 1 answer to suddenly 4. I still have to do the same thing with 5 pi over 12. And again, just going to add 6 pi over and over and over again. And I eventually should have 4 answers here, so I'm going to have 8 total. So if I add 6 to that, I'm going to get 11 pi over 12, 17 pi over 12, and then finally 23 pi over 12. If I do add another 6 to it, I get 29 pi over 12. 29 over 12 is bigger than 2 pi. So there are all 8 of my answers. So had that been a 3, then I would have had those for answers, and I would have had a 9 in the denominator instead, because I would have had to divide by 3. But that's kind of the idea. Whatever happens to x up here, it's going to do that to the number of answers you have. A little tricky, but once you get the hang of it, it's not so bad. Alright, the last 2, again, they look similar to problems that we've done, and for the most part they are, but these are ones that I wouldn't quite be able to do without a calculator. I can to a degree, and then I can't. Alright, so let's start doing as much as we can without the calculator. And first thing I recognize is I've got a squared term. That's great. I have a term that's not squared. They're not the same. So I can't start factoring or doing anything fancy like that right away. I do recognize, though, that the cosecant squared and cotangent squared are in the same identity. So I know I want to change that cosecant squared into something with cotangent. And if you remember your identity, cosecant squared is actually equal to cotangent squared plus 1. plus 0.5 cotangent x minus 5. And now notice I've got the same trig function, which is of course what your goal is a lot of times, and now I can try to solve. I'm going to kind of rearrange the order here. Looks like I have 1 cotangent squared. I have plus 0.5 cotangent x, and a total of minus 4 equals 0. Now, if you don't like seeing this, if you prefer to write x squared plus 0.5x minus 4 equals 0, and you want to factor or work with that, that's fine, and then you can switch the x's back to cotangents. It's nice if you can do it with the cotangents, but if you can't, I don't want you to get something wrong just because I want you to do it that way. If it helps to do it this way, do it that way. I probably don't want to deal with that decimal, so remember I could multiply everything by 10, and that would give me, well, it would give me a bunch of numbers without decimals. So I could say this is 10 cotangent squared x plus multiplying that by 10 is going to end up giving me 5. Of course, if I was smarter and thought about this, it'd actually probably be a better idea to just multiply by 2. That's actually the denominator, so I'm going to do that instead. So multiply everything by 2. Yes, if you multiply by 10 it'll work, but it's not necessary. Multiply by 2 gives me 2 cotangent squared x plus 1 cotangent x minus 8 equals 0. Alright, and now what I want to do is try to factor. Well, if I do the little multiplying front and back together, or earmuff method thing, I get negative 16. And if I start listing factors of negative 16, it's not going to take me too long to realize that I'm not going to find any that add together to give me 1. None of them add together to give me 1, which doesn't mean I can't do the problem. It just means it doesn't factor. And of course, if you can't factor a quadratic, you have no choice but to use the quadratic formula. And so that's what you're going to end up having to do for this particular problem, is with this equation, use the quadratic formula. And the only difference is, if it was this, we would say x is equal to negative b plus or minus. Well, it's now going to be cotangent x is equal to negative b plus or minus. So nothing is changing for the most part other than this isn't just an x. So cotangent x is equal to opposite of b, which is 1, so negative 1, plus or minus the square root of 1 minus 4a, which is 2, times c, which is negative 8, all over 2 times a, so 4. And now just continue to simplify like you would for any other quadratic that you're dealing with. It's negative 1 plus or minus the square root of, notice you've got 2 negatives here, so when you multiply this out, that's going to give you 64 plus 1, or 65 over 4. This isn't going to work out to be a nice number, and a lot of times we like leaving it like this. I can't here. I need to know a decimal, because eventually this is not my answer. It's whatever x is. So I'm going to plug into my calculator the square root of 65 so I can get an approximation here. Square root of 65. Looks like it's 8.06. So I'm saying the cotangent of x is equal to negative 1 plus or minus 8.06 divided by 4. And I'll go ahead and quickly find out those two decimals. So if I type in negative 1 plus 8.06, again, probably don't need a calculator to do this, and divide by 4, that's going to give me 1.765. So the cotangent of x is going to equal 1.765. That's one of them. And then if I do the other one, negative 1 minus 8.06, so negative 9.06 divided by 4, the other answer I would get is negative 2.265. Alright, so solving to get my two decimal answers, it's not x is equal to, so I got a little bit more work to do. Now, I don't normally like working with, cotangent. I'd rather work with one of the three originals, so I'm going to change this to tangent, which means I need to take the reciprocal. This right now is 1.765 over 1. I take the reciprocal of that. So 1.765, 1 divided by that, this is a fancy way of doing that, is going to be 0.56657. And then for this one, tangent of x is equal to negative 2.265. Take the reciprocal, it's negative 0.4415. Alright, so again, draw yourself the little unit circle. We're not going to recognize these numbers, which means we're going to have to use our calculator, but that doesn't mean I can't say what quadrant it's in. I know, for example, that it's in this particular quadrant. Tangent is positive. That means it's in the first and the third. If tangent is negative, it's in the second and fourth. And now, for most of us, it's easier to think in degrees, so we'll do that, and we can convert it to radians later. If I want to know what this answer is, I just have to type tangent inverse of that decimal. So I'll type in tangent inverse of 0.56657, and the calculator is going to tell me it's 29.5 degrees. Which, of course, this is 180 degrees larger than that, so if I add 180 to it, that tells me that this one is 209.53. Now, these are degrees, and they want radians, according to the restriction that they gave you, so you'll have to convert those to radians, which we'll do in a second. Same thing here. If I want to figure out what these angles are, type in the tangent inverse. So tangent inverse, negative 0.4415, and remember, that is this. It's negative 23.8. They're going to want positive angles because of the restriction. So I'm going to add 180 to it. That's going to give me this one, 156.2, let's say that is. And then add another 180 to it. That'll give me this one, which is 336.2. And now if you want to, you can convert all of these by multiplying them all by pi over 180. Now the other option you can do, if you don't want to do this and then convert, you can always change your calculator into radian mode, which in calculus next year you'll use this all the time because all the answers typically are in radians. I'm going to type in the tangent inverse just like I normally would of that decimal, 0.56657, and this time it tells me it's 0.51. Well, that's what this is in radians. If you multiply that by pi over 180, it's that. So I'm going to say x is equal to 0.5155, comma. We added 180 to this to get this number. Well, what's 180 in radians? It's pi. So if I add pi to it, there's this angle in radians. It's 3.6571, comma. If I switch this now, type in the tangent inverse of that decimal, so negative 0.4415, it's negative, that's this one, but it's giving me a negative answer. I don't want that. I added 180 to get to here, so add pi, 2.7258, comma, add another 180 or pi to and that gives me this one, 5.8674. And those are the answers that you would be looking for. So it's kind of how you want to do it. If you can think in radians, that's great because you'll have to be able to do that eventually. So you just switch your calculator to radians, type in tangent inverse, and then go through the same process. If that's hard for you to do, then figure out the degrees and just convert them all over later. Now, if you do switch to radians, I suggest, since this year we tend to work with degrees more, I suggest going to mode and switching it back to a degree so that you don't end up getting the wrong answer for a lot of the other things that we'll do. All right, on to the last one. Similar thing. You look at this one, tangent squared, tangent, that's great. I got the same trig function. I can't factor that, so unfortunately, got to go to the quadratic formula. So basically, same steps as what we just did there. And I'm going to have the tangent of x is equal to negative b, so negative 3, plus or minus b squared, minus 4 times a times c, all over 2a. Now, obviously, you're probably hoping that you get a negative number in the radical because then it's imaginary. You can stop and just say there's no solutions. But that didn't happen. So if I continue to calculate, I can see I'm going to get 5 over 2. This is one of those times where I don't actually want to know or simplify this with a radical. I would like to know what that is as a decimal. So I take 5, the square root of it, and I end up with 2.24, let's say, over 2. And then I'm going to find both of these numbers, so I'll take negative 3 minus 2.24 divided by 2. Make sure you hit enter before you divide by 2. Negative 2.62 is one answer that I could get. The other one, if I added 2.24 and then divide by 2, I end up with negative 0.38. And so for both of these, when I draw my little unit circle, they are both going to be in the second and fourth quadrants because they're both negative. That's fine. And then same thing, if you can understand how to think in radians, I think that's a good idea. So I'm going to do that. I'm going to switch my calculator to radians. I'm going to type in tangent inverse, so second tangent, negative 2.62. Hit enter. Now remember, that's giving me a negative answer right now. I don't want that because it's between 0 and 2 pi. So I'm going to add pi, or it's the same thing as adding 180 to get this answer. So add pi to this, and that gives me an answer of 1.9354. Add another pi to get this one, so plus another pi, and that's 5.077. Makes sense if you think about it. This is pi, this is 3.14, so 5 point something, that would make sense. If this is 3.14, 1.9, yeah, that probably makes sense. Do the same thing for this one, tangent inverse of negative 0.38. Hit enter. Again, that's giving you a negative answer. You don't want that, so you're going to add pi to it. And that'll give you this answer of 2.7784. Add another pi, or 180, to it. I say or 180, you can't actually add 180, but just so that you're thinking in terms of degrees or radians, it's 5.92. And there are your 4 answers for that one. So these two problems are very similar in terms of what you're doing. It's just understanding that for this one, you'd have to have a calculator. If you don't have a calculator on the test, you know you're not going to run into that because it would have to factor then. But if you do have a calculator, then something like that could happen. It doesn't change what you do, but the thinking becomes a little more in-depth, because when you get here, a lot of times you want to stop when you get that answer, but you have to realize you have to keep going. So good ones to look at. Hopefully that'll help you out with Section 3 altogether. If not, you're always welcome to come in for help.